Hello students, welcome to my new channel for higher mathematics. We will talk about going on a conjugate element and conjugate set. This is today's my topic. Okay students, now we will move on. What is this conjugate element and conjugate set? Okay students, so let's see this definition. Definition: let G be a group, G be a group. Okay students, G is any group and a element A is belongs to G. A is any element of group G, students, here. Okay, is said to be conjugate be A if there exists an element G in group G, students. Okay, such that B is equals to G a G inverse, and it is represented by is by BA. Okay students, now I can say that A is a conjugate element. Okay students, so what is the conjugate element of conjugate set? Because A is any element of group G, and if a other element G is exist of group G, then we can write V is equal to GA G inverse, that is denoted by B is that A is a conjugate set, students. Okay, from the definition, is it clear that B is B and A, and then B and A and AB? Okay students, as B is equal to GA G inverse. Okay, and is also mentioned here G inverse A, this B, G inverse BG, students. Okay, thus A and B are said to be conjugate element. B conjugate element. Okay students, and its relation is called conjugate relation. Okay students, now we again understand here G is a group. Okay students, G is a group and A is a element of G. Okay, and any other element B is belongs to G. Okay students, and A element G of group G is also included here of group G, that we can say that B is equals to A G inverse A G students. Okay, this condition is equal to the B, then we call A is conjugate. Okay, then we can set A is conjugate and represented by B A. Okay students, is also represented by A B. Now students, we discussed about conjugate set. What is the conjugate set? Okay, conjugate set. Okay students, we can define the conjugate set: two subject A and B of a group G. Let A and B any two element of group G students. Okay, and group G are said to be conjugate to each other if a condition is applied here students, if there exists an element G in G. G is also denoted as element students. G is belongs to G. This is element of group G students, such that B is equals to GA G inverse. Okay, that is the opposite of conjugate set students, and we can also write here A is equals to G inverse B G. Okay, and this is called conjugate set students. Okay, this is called conjugate set. Now according to this property, conjugate set and conjugate relation, we can prove a theorem. Okay students, now we take any one question, an example. Okay, the example is a group G is an equivalence relation Okay students, now that is the very most important question student for next examination. Okay, MSc, we want to prove that G is a equivalence relation. Okay students, it means G is a conjugate set also included here, and G is a conjugate element and conjugate set students. Now first we shall that the conjugation relation is reflexive, symmetric and transitive. Okay students, conjugation relation is said that's reflexive students, reflexive. Okay, symmetric and transitive. Now we take three element A, B and C is belong to G students. Okay, A, B and C is a three element of group G. First, reflexive. Okay students, reflexive, we can easily prove it that G is a reflexive. Okay, let A belongs to G, it means A is any element of group G. Since E belongs to G, what is the G? And D is a E is a identity element, students. E is identity element. Okay. Therefore A is equals to E inverse. Okay. Then A. Okay, this is the according to conjugate set. Okay, students, for all A belongs to G, we know also that. Okay, thus so G is reflexive. Okay, students, A is set. A is element of group G and E is element of group G. E is the identity element, and this property A is equals to E inverse, because E is a identity element and A is also mentioned here. Then E and E inverse is equals to 1, students. So we can write here A. Okay, so behalf of this rule, G is a reflexive. Now second, this is the first one. Second is symmetric. Now A and B are two element of group G, such that A and B. Okay, student, what is this? This is B is a conjugate set. Okay, B conjugate element, student. Set, not set, this is conjugate element. Now we can write here A is equals to XB X inverse. Okay, what is this is A element X inverse and X. Okay, we multiplied here, this is we multiplied here X inverse A X is equals to X inverse XB X inverse and X. Okay, students, we can trick applied here, X and X inverse and multiply here. This multiply is written here and also we write here. Okay, students, this is, we can write here X inverse A X is equals to X inverse X, because this is the identity law, and second one is B X inverse X, students. Okay, and this is E, B, and this is E, students. What is the E? E, we already know that E is a identity element, students, and now we can say that B X inverse A X. Okay, students. And now B is equals to X inverse A X. Okay, because X inverse is also belongs to G. Okay, students, X inverse is also belongs to G, because X belongs to G. Okay, we can say that X and X inverse belongs to G, and this condition is E is also belongs to G. Okay, students, now according this condition we can say that F is reflexive, F is symmetric, students. Okay, F is symmetric. And now our third property transitive. Transitive, students. Okay, what is the transitive property? Transitive is let a b and b the c, then exist x. Okay, students, this is a new element of group G. X and by in G, such that it means x and by an any element of group G, students. Okay, we can say that a is equals to x b x inverse. Okay, and b is equals to by c by inverse. Okay, a is equals to x and b is right here, students. So b is replaced by this property by c by inverse, and this is x inverse. Okay, a is equals to x by, students, this is one, and we can write here c, this is c by inverse and x inverse, students. Okay, we can say that x by c, x by inverse. Okay, students, now xy and xy inverse, a is equals to c, because xy and xy inverse is equals to e, students. Now e and a equals to c. Okay, this is proving that this f is a transitive. F is transitive, and now as f is transitive, f